All right, lam2 is capturing I by reference. That means that when I execute lam2, if I is changed within lam2, then that change will be reflected back in I within the main function. In other words, since I is being captured by reference here, and I's initial value is 4, what happens in the body is that 4 gets replaced with 12, that is 4 times 3. 12 is displayed when I call lam2, and then when I display the value of I after lam2 has been called, I'll discover, I has been changed to 12. Okay, so I define lam2, I capture I by reference. I first change I's value to 3 times itself and then display I, so that's the blue 12. Then in this red cout statement, when I display the value of I get 12. However, that doesn't affect what's going on in the lambda definition where I captured I by value, because when I captured I by value, the value I captured for I at that time was 4. So when I call lam1 again, I still get 4 for the value of I at the time that lam1 was defined, and 0.125 is the value of x. Okay, so finally let's take a look at how we can use lambdas with algorithms. On slides 13 and 14, we have a small example program, and the output is shown here on slide 15. So let's walk through this example. Here I have a local variable named capital N, initialized with a value of 2. I have a vector of int, v, that's initialized with 7 values. And we'll assume, because I've got my tools included here, that the OStream iterator, OSISP, is available to me. That displays to the cout output stream integer values separated with spaces. And so if I copy v from begin up to but not including end, that will simply display the values that are currently in v. So no lambdas going on yet, we just displayed the initial contents of v. Now, in the green code here, I've specified the definition of a lambda expression, and I've got the name addN for that lambda expression. Notice that in the lambda, we're capturing the local variable capital N by reference, and this lambda takes an integer argument, which we're calling x, and what this lambda will do when it's called is to simply return the argument that's been passed in plus the current value of n. Alright, so now we're going to call a transform algorithm using addN. We're reading from v, from begin up to but not including end, and we're also writing out back into v. So the upshot here is that each value within the vector of int v is going to have 2 added to it. Okay, the argument to the addN lambda is the value that we're reading from v. When we call the lambda with that argument, what we get back is that value plus whatever n's current value is, which is 2. And so the upshot should be, when I look at the result in this green copy algorithm, I should now in v have the same values where each value has been increased by 2. And that's exactly what I see. So 1 got replaced with 1 plus 2 is 3. 5 got replaced with 5 plus 2 is 7. 3 got replaced with 3 plus 2 is 5, etc. Since I defined my lambda addN, capturing capital N by reference, when I now continue on to slide 14, and I change capital N to -4, because capital N was captured by reference, in the add n lambda, when I now do the same transform statement with add n as the function being applied, this time around, each value in v is going to have 4 subtracted from it, instead of 2 added to it as we had in the previous transform. And so now when I see my output from the red copy algorithm, sure enough, 3 minus 4 is minus 1, 7 minus 4 is 3, 5 minus 4 is 1, etc. And finally, one more time, I'm setting n to some different value. This time capital N is going to be set to 1. And when I do my transform, every value in v is going to have 1 added to it. So I now have 0, 4, 2, 1, etc. Okay, so that's an example both of using a lambda as the function to be performed by a transform, and in the lambda we specified capture of this capital N variable by reference.